Okay, guys, so day 3, we're going to talk about trig and logs. I know it says trigs, it's supposed to say trig. You should say, hey, ding, 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 this chart looks similar to something we did a couple weeks ago with my unit circle. That's because it is. I want you to go ahead and pause this video and try and fill out as much as you can in the chart, and then come back together and we'll go through it together. Okay, guys, so after you've tried it, you notice that the difference between this chart and the chart we saw 2 weeks ago is the 2 week ago one went up and down, the degrees went up and down, and the trig part went on the across the top. So we talked about the basic 4, and by the basic 4 I mean, here's my little crosshairs, here's my really bad attempt at a circle. The 4 coordinates that hit on either side of the axes. So I have one here at 0, 360. I have one here at 90, 180, and 270. And we also talked about how those coordinate points went cosine, comma, sine. Well, let's at least get those 4 done. Well, at 0, 360, I know that point is 1, 0. At 90 degrees, that point is 0, positive 1. At 180 degrees, that spot is negative 1, 0. And at 270 down below, that is at 0, negative 1. So we at least got those basic 4 in. And I told you we were going to work on talking about getting to this part on its own, which we'll get there in a second. Now let's talk about my 45 degrees. We liked those ones because those were the exact same depending on which version of a 45 degree angle we're working on. When we're talking about just plain old 45, it's the same number twice. We like those. Next was the hardest part of 60. And 30, I'm sorry, 30 and 60. They use the same numbers, so we know we're going to have a square root of 3 over 2, and we're going to have a half someplace. Well, I know that it goes cosine, sine, and the trick that I always remembered is that the first coordinate of 30 degrees dealt with root 3. So that means that my sine has to be a half. And conversely, those guys flip. So we at least have sine and cosine done. Now talking about tangent, I don't want to go too far because I still want to be able to see. So I'm going to go ahead and erase that stuff. You guys can write down below. I just don't want to scroll down too far because I want to make sure I can see what my degrees are at the top. We're going to get into this a little bit more here in a moment. But my trig functions are all made out of sine and cosine. I know tangent, you're like, but tangent's its own thing. Here's something cool. Tangent is equal to sine over cosine. Oh, I don't want to make that bigger, I just wanted to write. So, if we take a look, we can determine what my tangent is going to be. It's not something I actually have to memorize. It's something I can physically calculate. So 0 divided by 1. What is 0 divided by 1? That one's just 0. We're going to do the basic 4 first. Man, those look like the same colors. I didn't want them to be the same. Okay, what about 1 divided by 0? Can I divide by 0? Nope, I can't divide by 0. So this tangent does not exist. So similarly, we know that this tangent for 270 cannot exist. Even though we're taking 0 divided by -1, 0 is neither positive nor negative, so it's still 0. That's pretty easy. Well, if I take root 2 over 2 divided by root 2 over 2, it's the same thing over the same thing, and we know that anything over itself is just 1. The 30 and the 60 is a little bit more complex. Again, I'm going to erase this so that I can have room to write something new. Don't erase yours, keep it. Just write off to the side or down below. When I'm dealing with 30, I have a half divided by the square root of 3 over 2. And we know with fractions that we don't ever divide, we flip and multiply. We try and cross cancel whenever possible. And I know that 2 on top and 2 on bottom will cancel out. So that gives me 1 over the square root of 3. Now, if you recall way back in your math B days, you learned that you can never have a reciprocal, you can never have a radical on the denominator. So in order to fix that, you multiply both sides. By both sides, I mean you multiply the top and bottom by the square root of 3. Square root of 3 times square root of 3 is 9. Square root of 9 is just simply 3. So the tangent of 30 degrees is root 3 over 3. Same process here to do the 60 degree. Again, I'm erasing so that I can keep my stuff at top. You can put yours down below. You have plenty of space. In this case, I have it flipped. I have root 3 over 2 over a half, which is the same thing as root 3 over 2 times 2 over 1. And again, we're going to do that cross-canceling out. Well, then I have the square root of 3 over 1, which is just the square root of 3. So the hardest part in all of this chart is the 30 and the 60. Both finding the sine and remembering the sine and cosine and determining tangent. And I say they're the hardest because if you can't remember what tangent is, you have to physically show your work. I can easily divide 0 by 1. It doesn't exist. And I can say, hey, I'm sorry, it's just 0. 0 divided by 1 is 0. I can also try and divide 1 by 0 and know that doesn't exist. I know the same thing over itself is just 1. Those two are the hardest part. So, out of this chart of 1, 2, 3, 4, 5, 6, 7, out of this chart of 21, you have, what, 6 spots that are hard? You can do it. So that leads us into using some trig. And we talked about SOHCAHTOA last year. We talked about it right at the end. I wish I would have gotten to it sooner, but unfortunately it just didn't happen. And we know that SOHCAHTOA stands for sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Ooh, that's really bad H. And tangent is opposite over adjacent. And I said that everything is created out of sine and cosine. And so far you've only ever seen just tangent. So tangent's my only other one that's not sine and cosine. Today we're going to talk about some other stuff. We're going to talk about secant, cosecant, and cotangent. So secant, and I'm going to switch up my colors here and try and write as best as I can. Secant is shortened with SEC, so it's not second, it's secant. So secant of x is actually the reciprocal of 1 over cosine. So they're equal. Cosecant which is shortened as CSC, is 1 over sine. Cotangent which is shortened as cot, is 1 over tangent, but if you remember, tangent was sine over cosine, so if I flip it, it's also cosine over sine. And we again also talked about how tangent, even though it seemed like its own thing, was actually just sine over cosine. And I want you to have that so that you don't forget, because you may want that for your homework. If you can't remember that tangent is sine over cosine, you are going to want that for your homework. I'm telling you that right now. Well, keeping with our SOHCAHTOA, we're going to use the reciprocals here in a minute, but keeping with our SOHCAHTOA, we're going to go ahead and find my x and y values. I know you don't have the most amount of room, but you have enough room. If I did it myself, see, da-da-da. So let's go ahead and focus at my angle of 20. And focusing on 20, I know that 7 is my opposite side, my x is my hypotenuse, and my y is my adjacent. So what do we want to find first, x or y? Doesn't matter. Great, let's find x. So if I'm looking for x and I have my opposite and my hypotenuse, yay, sine. Okay, so we're going to do the sine of 20 is equal to the opposite over the hypotenuse. And we want to solve for x, and right now x is in the denominator, so we're going to multiply it over. So we have x sine of 20 is equal to 7. But I want to solve for x, so I'm going to go ahead and divide both sides by sine of 20. So x is equal to 7 divided by sine of 20. Now, in your calculator, make sure you're on degree mode. And if you're not sure, please let me know. And when I go ahead and take 7 divided by sine of 20, I get 20.5. So that's my x value. And then let's go ahead and talk about my y value. So y, I have opposite and adjacent. So which one uses opposite and adjacent? Good, tangents. So I have my tangent. Ooh, that was too far. I don't see my numbers. I have tangent of 20 is equal to opposite over adjacent. And if you noticed, because I try and teach tricks while we go, it's set up exactly the same way with my variable on the bottom. And if, once I did my work, I ended up with my trig on the denominator. Same thing's gonna happen. I don't want to write in my face. So it's going to be y is equal to 7 divided by the tangent of 20. It'll always happen that way. If your variable's on the bottom, you'll end up having the same number on top, just switch your spots. When you plug that one in the calculator, you get 19.2. Alright, second triangle, woo! Here's my focus angle of 30, 9 is opposite, y is my hypotenuse, x is my adjacent. Pause video, find those two values for me, please. Alright, your x should be 18, and your y value should be 15.6. Remember how I said we were going to deal with those trig guys here in a minute? These three equations are called trig identities. Identity usually involves with having something be equal to 1. Or itself. It deals with something involving itself most of the time. Usually getting to 1. These three trig functions will be used throughout the year. I know this is a new concept. If you know one, you know all three. So we're going to start with the mama, because without the mama, you have nothing. The mama, which is one of the main three, is sine squared. Now it means that the sine of x is quantity squared. But if I write it, don't actually write it this way. If you write it like this, you assumed your x is squared, but that's not the case. I want the entire thing squared. So when we talk about squared things with trig functions, the squared part goes after the trig. So it's sine squared x plus cosine squared x is equal to 1. Now we know we can manipulate functions. We can add and subtract whatever we have. We can move things around. Well, what if I wanted to move sine squared to... No. What if I wanted to move sine squared to the other side? Well, it's adding, so I would just subtract it. So if I subtracted it, I would see cosine squared is equal to 1 minus sine squared. What if I want sine squared by itself? I wanted to move that cosine to the other side. Same idea. Then it would just be sine squared is equal to 1 minus cosine squared. Well, what if I wanted to move more than just one thing? What if I didn't want 1 minus? What if I wanted sine minus 1? What would that have to be? Well, if I subtract the 1 over here, I have 0. So I'd have to move this guy over with a negative, so he'd be negative cosine. And similarly, if I had cosine minus 1, cosine squared, I'm sorry, minus 1, that would be equal to negative sine of x, sine squared of x. So all I've done between my original equation in black and all these different versions in red is manipulate with addition and subtraction. Well, I know I can manipulate with division and multiplication. Well, when I deal with my trig functions, we talked about here with my reciprocals that it's all division. They're fractions. Fractions are just division problems. So we're not going to do any manipulation with multiplication. We're going to do some manipulation with division. And again, everything comes from the mama, so the papa and the baby are created from the mama. In order to create the papa, I'm going to divide by sine squared. And I'm going to do this to every single thing. So I'm going to write this in off to the side. I'm going to write it down here. This is not my actual thing yet. I'm going to divide every single thing by sine squared. And the resulting factor will be actually the papa. Well, I have sine squared over sine squared. It's like saying 3 over 3. What is that going to be? Good, it's just 1. Cosine over sine. Well, just ignore the squared part for a second. Let's look at what cosine over sine was. Cosine over sine, well, that was cotangent. So now I'm going to have 1 plus cotangent, and he's going to be squared since they were both squared. What about 1 over sine? What was 1 over sine? Ooh, that was cosecant. So your papa is your mama divided by sine squared. And again, just like with this one, with the mama, how I had all those different variations in red with addition and subtraction, I can do the same thing. I can have it equal to cosecant, I'm sorry, let me try that again. I can have it equal to cotangent squared by taking cosecant squared and subtracting 1. Or I could have this equal to 1 by taking cosecant squared minus cotangent squared. And again, I can make them equal to the negative versions of each other. I think you can handle that one on your own. Next, we're going to take a look at finding the baby. Well, I've already told you the papa and the baby were created from the mama. To determine the papa, I divided by sine squared. What do you think I'm going to divide by to find the baby? Well, what did I tell you all trig functions are made out of? Sine and cosine. So I'm going to take the mama, which is sine squared. Nope. Thank you. Just sine squared x plus let's try this again. Which is sine squared x plus cosine squared x is equal to 1. Well, to find the papa, we divided by sine. So to find the baby, we're going to divide everything by cosine. Well, what was sine over cosine? Sine over cosine was tangent. And again, since they are both squared, my answer will still be squared. So baby starts with tangent squared. Cosine over cosine is just 1. And 1 over cosine is secant. And again, just like with the mama and the papa, I can create the other manipulations with addition and subtraction as soon as my computer responds, so I can switch colors. Or just responds in general. Come on, computer, unfreeze. Alright, well, stay tuned for part 2 since my computer just froze.